Okay.
Because you have too big of a trackpad and your computer's messed up.
He thinks my trackpad is too big.
It is too big, I can't.
Oh, what class is this? 250. Okay. So what I'm going to do, since we only meet once this week, because we have fall break, right? I'm going to start talking about Android stuff today, so we can segue towards that, because I want to start using Android starting next week. Somebody want to hit the third button down so there's less glare or whatever. All right. So we're going to be doing Android development in here. So the language, still Java. This isn't like a special version of Java. It's Java. There are some classes that we'll be using that are specific to Android, just like we've used the random class and we've used the array list class. There are classes like called view and, button that we use in Android that we might not necessarily use on a console-based Java application. So the language we're going to use is Java. The tool we're going to use is called Android Studio. Okay. So this is instead of Eclipse. So this is called our IDE, Integrated Development Environment. I'll put that in the next line. Okay. Now the normal cadence for an Android application is to, and actually real quick, I'm going to open up Android Studio just in case there's updates I need to run. I'll have it running in the background while I'm doing this other stuff.
Do you need to download Android Studio?
Yeah, I'll show you in a second. I already have it on here, so let me just run updates and stuff behind the scenes while this other stuff is cooking. Okay. So Android Studio, you'll go to, I'll put the link in here, developer.android.com. And then at the top, we have a thing that says Android Studio. Yeah, so you'll get in there and download Android Studio 3.5.1. Looks like it's the current one. And I'm assuming I still have that one, or that's the one I have, but we'll see in a few minutes. Anything I'm going to talk about at the very early stages should be pretty similar. Well, that's showing Android 3.4. Oh, so I'm guessing this is 3.5 now, because it's having me delete 3.4. Yep, what's new in 3.5? Okay, so I have the latest, greatest, whatever now. All right, so you'll go here to Android Studio. I'll actually put this link in the, Ninja. So there is the link in the slides. I can put it on Slack too. There you go.
Yeah, mine was going fast and everybody's like, oh, right now it's
Just do it at home.
Okay, so you download Android Studio. Now let me talk about, at the high level, the components of an, oh, go ahead.
I think I remember using it during a hackathon last semester.
Yep.
It's basically an Android app developer, right?
Yeah, if you did an Android app in the hackathon, you probably downloaded Android Studio. So just open it and run any updates to bring it up to the most recent version.
Which is going to happen
It happens fairly often, but it looks like since last semester, I don't know, have I done any Android this semester? Yeah, since last semester, there's a not a major revision, but a partial revision from 3.4 to 3.5. Okay, so these are the tools that you're going to be using. So we're going to still use Java. We're not switching languages. All right, we just kind of get this new collection of objects available to us that are Android-esque objects, okay? The tool we're going to use for development is called Android Studio, and we're going to use that instead of Eclipse. Now, fun fact, as Sheldon from Big Bang Theory would say. How many of you have seen that show? Yeah, so he goes, fun fact. Fun fact is in the early days, Eclipse was actually the tool you used, and there was an Android plugin for Eclipse. So what you'll notice is in Android Studio, it has a very familiar feel to Eclipse. Eclipse is an open source project, so what Google finally did is they took the open source version of Eclipse and they built Android Studio on top of that with their plugin already embedded. I'm not sure if they still move Eclipse stuff into it or now it's just its own product. But when they initially did I guess I'm presuming or assuming that they started with a Eclipse base since it's open source, but it's possible they didn't, but they look a lot alike. So more than likely they took Eclipse, put their plugin into it, and then kind of refreshed it to make it look more like a single integrated environment for doing Android applications where when you used Eclipse with the Android plugin, it was a little wonky. You know, it was fine, but it was a pretty primitive experience. And during that time period, if you were a developer and you were comparing it to the iPhone development environment, which is called Xcode on Macs, it was a pretty far cry. Xcode was a significantly more polished tool. Now, you might say in general, Apple stuff is a little bit more polished than other people's stuff, but I've said this in several of my classes before, but I'll say it again, is Apple solving an easier problem, right? When they're writing Xcode to work for iPhone, they're writing a piece of software for developing for their exact hardware. So they control both sides of that equation. They are able to make it very customized for that, right? In the early days, it was really customized because every single iPhone was the same size. Now we've added a little deviation where not every iPhone is the same size. We have like 3 or 4 different screen sizes now, but still we're only targeting 3 or 4 devices on the iPhone side, and then 3 or 4 size differences on the iPad size. So they're still solving an easier problem than Google creating a piece of software, Android Studio, that allows you to develop for we'll just round down and say 4 million different Android devices, right? That all have possibly little different screen sizes, even if it's like 0.1 inch difference or a different pixel count. It seems like every new phone that comes out has like some tiny difference than like last year's model. That's one more deviation from a standard, right? Okay, so you can imagine that creating the Android Studio tool is a hard problem to solve. So keep that in mind when you're using Android Studio and you kind of feel frustrated because sometimes it's a little wonky. I promise you, after you've been using it for a while, you kind of get the hang of it and you can pretty much figure everything out. You might have some weird situations where certain things, it just isn't doing what you expect it to do or something. But it's way better than it used to be, and it's constantly improving. It's not as good as Xcode, but if Xcode's a 10, Android Studio is at least a 7, something like that, where it used to be a -8 when it was a plugin for Eclipse. Yeah, -8 is bad. That is a bad tool to be developing with. You don't want to be developing with a -8. That tool goes out of its way to change your keystrokes. True story. All right. And this is actually very related to the Microsoft problem, right? You have the Apple fandom, right? And they go, oh, Mac is so much better, blah, blah, blah. Well, so we can say, is the Mac OS maybe a little more polished than Windows? Sure. But the OS is running on just their hardware. They're able to really tune that for exactly their machines. Or how many different computers is Windows running on? Round down and say 8 million? Right? With different hardware configurations and different size monitors and all sorts of different things. So if we say Mac OS is a 10, really Windows is probably a 9. It's pretty solid, right? I mean, it's not far off. So Microsoft's done something pretty special with their operating system, and they're pretty commonly demonized for, oh, it's not a Mac or something like this. But Apple solved the easy problem there. Microsoft said, oh, we're not going to make hardware. We'll just write software that runs on everybody's hardware. And oh, by the way, it has to be actually reasonably good. So keep that in mind next time you're complaining about Windows or there's some, quirky thing that's happened because your setup is one of, 8 million rounded down different computers that software runs on. All right, go ahead.
Just a quick question. I don't know if you're going to cover it, but is this compatible with the GitHub?
Yep, more compatible.
More compatible?
Yeah, well, I mean, you can do it all from within it. You can do that on Eclipse as well, but it's a little bit kind of wonky to do it in Eclipse. And if we were doing Eclipse longer, we would have gone through the process. But since we're going to be doing Android Studio for a while now, and Android Studio has a pretty convenient tool for just checking your project with a drop down into GitHub. You don't have to do any weird moving files around or anything like that. Yeah.
So it's more intuitive?
Yeah. We'll see it when we go to it. All right. So if you remember when the Acuity students were here, one thing they talked about was this idea of design patterns. Remember that guy? All right. Have we talked about design patterns before? All right, so let's give a definition for this guy. So a design pattern is a proposed, I'm going to put in quotes, good solution to a, quote, common problem. Now, what I'm going to say is design patterns were invented by academics. How many of you have heard the phrase publish or perish before as it relates to academics? So when you're less so at Concordia because we're mostly a teaching school, but you have kind of two different universities, two different kinds of universities. You have teaching universities and you have research schools. So teaching universities tend to be about 80% teaching, 20% research, where research schools tend to be kind of flip-flop that. So you have a lot of TAs and stuff teaching the classes because they're bringing in their dollars through research. So in those research schools, this idea of publish or perish is really a big deal. That is, your salary is based on you doing research, writing papers, and publishing it in fancy schmancy, conferences, so that you make the university look more impressive, and that's your job, is to publish and make it look like really great research is coming out of that school. Concordia we have a small part of our job load is based on research and getting promoted through the ranks of professors. So you have instructor, assistant professor, then associate professor, then full professor. So that moving through there, especially going from associate to full professor, requires fairly significant research stuff. But what's interesting, and this is where the story comes in. So because in academia we have this idea of publish or perish, I'm going to say design patterns were invented, where if you look at this definition here, this is a proposed good solution to a common problem. How many common problems are there? Round down and say 14 million?
Millions.
Just keep going up. What's a common problem to me might be different. I mean, a common problem at Lockheed Martin might be something with missile tracking. Right? Wind shear to how a missile hits its target or something like that, where a common problem to a chef might be making sure the sugar doesn't burn, right? All sorts of different things translate into what's a common problem, okay? So each individual can say, these are common problems in my world. And then what's a good solution? I always kind of go back to most of us in here, I think at some point in time have made a peanut butter and jelly or a similar type sandwich, right? Okay. So what's the right way to make a peanut butter and jelly? Do you put the peanut butter on one piece of bread? Do you do the jelly on the other? Like, you know what I mean? You can have 3 or 4 different kind of approaches, and you don't want to tear the bread, right? See, I think what's the best approach. Because you know, spreading peanut butter can sometimes be kind of problematic. You might tear the bread and stuff like that. So I put it on like in globs. And then I put globs of jelly on there. And then I put the lid on and I just smash it. Boom, spread. All right, so bottom line is I could release a research paper on the right way of creating a peanut butter and jelly sandwich where you could come up with 10 other possible solutions to peanut butter and jelly. Mr. Gonzalez's version is stand on the other side of the room and just chuck it at the bread. It's still closed in the bag. He doesn't really understand how that works, but you get what I'm saying, right? So we can come up with as many good solutions to as many common problems as we want, which makes it good from a research perspective. Because research doesn't mean propose something that's going to be used. It could be, I looked into this problem closely. Here is a solution I thought was a good idea. Result? No, it wasn't. That's research. That's moving the area of focus forward, right? At some point in time, somebody had to do something with, you know, some kind of mechanic or, you know, a mechanical device or something where it exploded, and they had to write about it and say, don't do that. Okay, it's bad news to do these 3 things in that order because it does not work. I'm lucky to be alive type thing, right? All right, so research can be forward moving or telling you something not to waste your time on. And almost always design patterns have a funky name. It's not a rule, but it tends to be a naming convention. All right, so we're going to talk about our first design pattern in here, and it's something called MVC. MVC design pattern. This is Model View Controller. That's what the MVC stands for. All right. Now, and this one doesn't really have as much of a funky name. The other ones we're going to look at are going to be like Singleton, Observer. They talked about the factory design pattern. Usually it's some kind of weird name that's somewhat meaningless. All right, so Model View Controller. The generic statement would be this. It's a good idea to keep your logic separate from your interface, separate from your data. So in this, model is your data, maybe stored in a database, but somewhere. You know, we could store it in a local file, we can store it wherever, but our data lives in one place. Those are our models. Our view is our interface. This is what the app looks like. And our controller, this is our logic. What makes the app work? All right, and we can kind of go all the way back to when we talked about object-oriented version of the telephone. If you look at an old-fashioned telephone, you know that there is an interface that you're looking at that has the buttons on it or the little twisty thing that you put your finger in. And you know if you were to lift that off, you'd find wires underneath there, right? So that front panel that looks like the telephone dialing device, that's an interface. And when you pull that up and you see all those wires, that's the controller. And you've just connected them behind the scenes, all right? So it's a good idea to keep your logic separate from your interface, separate from your data, and have a mechanism to connect them at runtime. They ultimately need to talk. Okay, when you hit a button on that telephone, it's not going to work unless your wire is hooked up behind it, right? But as a human being, we don't want to be messing with these wires. Go ahead.
So we talked about interfaces last time, and I was
Different kind of interface.
Okay,
Yeah.
okay. I was just wondering if I could get some clarification on it.
Yeah, good point. different than the interface where we say a product must be compatible with a certain standard. Yeah, it's I would say with MVC in mind, think about interfaces in terms of maybe we can call this user interface. Sometimes this is just called UX, user experience. That's what we're really talking about here, where that idea of an interface in an object-oriented language is really saying that these things must adhere to a standard so that this thing can interface with these types of things. So the word interface itself says that something can connect to something else accurately, right? When we talk about a user interface, we're typically talking about the human being being able to connect to your code. Does that make sense? Go ahead in the back.
Oh, I was gonna say, so, the interface that, we talked about last class is the actual system that the barcode uses to figure out information.
Yeah.
But the interface that we're talking about now is kind of like the thing that the person using the barcode scanner would look at to figure out.
Yeah, it's what the human sees. Yeah, so if you just remove the word interface from it, I mean, really we're talking about two separate things. So maybe I was misleading when I just called this interface. This is really what we see as a human being, what the app looks like, what we see and click on buttons and things like that. So our user experience, that's what we're talking about with MVC. Where that idea of interface in Java, since it's an object-oriented language, has more to do with we have one system that needs to be able to interface with another system, and here we use an interface structure to define what rules that interface must follow. Here's the 6 things that must occur in order for it to be compatible with that interface, right? If you have an Xbox and you want to plug it into your TV, what must you have? HDMI cable, right? That's what interfaces the two of them. So your back of your Xbox has said, we're going to follow the HDMI standard. The back of your TV says, we're going to follow the HDMI standard. So now all you need to do is connect a cable to each side, and now they talk to each other. Make sense? So in that case, HDMI standard would be an interface related to the Java interface we talked about last time, where what we're talking about here is a user interface like I'm working with this application. All right, that clarify? Yeah, that was my fault. I'm using those terms interchangeably. Okay. All right, so questions about MVC. Keeping in mind design patterns are ideas, not implementations. These are ideas, not implementations. That is to say that we're going to be seeing how Android Studio accomplishes the idea of MVC, which is going to be similar but not necessarily identical to how Xcode accomplishes the idea of MVC, which will be similar but not identical to how Visual Studio for .NET development accomplishes the idea of MVC. Make sense? MVC is the idea of keeping your data, your interface, and your code in different places so that they don't start jumbling together, because things can get pretty complicated pretty quickly. Yeah.
Sorry.
That's fine.
I was just going to say, so is it kind of like what we were doing in Eclipse when we had the package with all the different classes in them to separate out the individual things? Like they had a thing that was combined.
I would say not really, because really in Eclipse, we haven't dealt with data and we haven't dealt with interfaces at this point. So I would just call that organization. If you have a whole bunch of shoes at your house, you sometimes might want to have a little organizing thing so you can kind of keep track of, which shoes are, your tennis shoes versus dress shoes and that kind of stuff. So yeah, I would say this isn't, not to be confused with general purpose organization. MVC is really talking about a very specific problem. And that is the problem of, let's kind of jump ahead here. Let's see, where did this come from? It's possible it had some early thing someplace else, and it's not a far-fetched idea, right? But I'm going to point to at least a good example of kind of the time period where this came into. So we have this language called PHP. So PHP is a web-focused programming language. All right. So when we deal with web pages, we're typically thinking about HTML, JavaScript, CSS, which actually wasn't really a thing back then, but we'll throw it in there just to sweeten the pot. Those are when we think about a website. So web, at the very baseline, is going to involve those technologies. HTML is how we make our interface look like something. If I come back to a web page here and I right click on this and I say view source, what I'm looking at there is HTML and JavaScript. All right. This does not look anywhere near as pretty as that. Right? Human beings want to see this. This is our user experience, whereas behind the scenes, what's happening is there's a bunch of funky code that gets translated, gets interpreted by our web browser, and turns it into pretty pictures like this. That's the web experience, right? Okay, so now if I go in to sign in here, for example, oh, it automatically signed me in. Let's assume that it had just brought up the a username and password box, and I chose not to put anything in there and just hit submit. Chances are JavaScript would kick in then and check my inputs before it tries to send my credentials over the internet and say, hey, you didn't give me enough information to even attempt to log in. So JavaScript gives us what's called client side. So we're dealing, I'm the client. Here's my web browser sitting in front of me. JavaScript gives us client side processing so we can do things like that. Form validation, making sure you filled all the fields in before we're going to go send it to a server over the internet somewhere. Make sense? So JavaScript, if we just kind of come back here. So we'll say web is HTML, JavaScript, CSS. So this is our tool. Well, I'll call it language. Language for describing our user interface. JavaScript is a programming language, okay? Not to be confused with a data representation language. In fact, I'm going to call this guy data representation language, because we've described that programming languages all have facilities for memory, asking questions, repetition. JavaScript allows you to define variables. It allows you to ask questions, if statements, and it has loops and functions and that kind of stuff. Interesting, fun fact, JavaScript has nothing to do with the Java programming language. They actually just share that word. Yeah, but it was during a period of time where it seemed like a lot of those things that, the early, I don't even know if the logo still has that. Does the logo have the coffee steam thing coming up for Java? Yeah, Java is related to coffee, because like one of the early IDs, the competitors with Eclipse was called NetBeans. Coffee beans, haha. So at some point here, I think we're starting to see the early days of these programming languages coming into existence as we had freelance web developers. These guys hung out in coffee shops. They're just looking at, what should I call my language? Latte. And I think there is a language or framework called Latte, or there's probably pumpkin spice latte too. We just keep circling around. That's what we do, right? We just look at what's around us and figure it out, but there's real truth there, all right? So HTML, this guy is a data representation language, and this is really important. So what I'm showing you here, and we're gonna do some of this stuff I think you'll probably do some of this stuff in the 430 database class, But in the future, we're going to actually have a web-specific class starting next year, so you'll be able to take it as an elective if you'd like. But what's interesting about web, and one of the things that our students have said quite a bit as they come out of college, is we don't focus on web enough. Now, what's interesting is web feels boring. It's old. It's been around since the beginning of the internet. But how often do you guys go to websites?
Most every day.
Okay, it's not going anywhere, right? The issue, what I would argue from a computer science perspective, and it's not a great argument against having a course that deals with web, because the principles are still there. You know, we're going to see MVC in web development, because I'm about to tell you where MVC came from relative to web development. All right. So I don't want to devalue it, but if you go on to like a freelance developer website, pun intended, I guess, you know, where you're looking for somebody to help you, develop some software for something, you're going to find a disproportionate number of web developers. So I might say that a web developer is kind of a dime a dozen. There are a lot of freelance programmers that their skill set is in web development. Now, a traditional computer science person, traditional programmer, let's say, they might say, well, they're not real programmers. Now, having said that, if you took 10 web developers, there's probably a pretty good chance that only a couple of them would fit into that category of, let's say, real programmer. That doesn't mean they're a bad programmer. It just means that they have a focus. They're good at what they do. They're good at applying computer programming in the context of web development. Now, having said that, web developers bring more to the table typically than just programming, because they're also designers, right? They need to make your interface look nice. They also need to be comfortable with databases if they're going to be kind of a one-stop shop. So a common web designer or web programmer, they might create a MySQL database, put the data in there, create a nice user interface for their application, and then build the logic behind that to make it work. Now, fine, they might not be writing a video game or something like that. They're basically creating that idea of like a telephone where they have pretty user interface, some wires behind the scenes. Ultimately, it has to go and do some stuff. All right, so maybe the types of problems a web designer have more to do with giving end users conveniences rather than solving, really complex business solutions, even though there's plenty of websites that do some of those things. So that would probably jump up to that next level of expertise that would be required. Okay, but I think one thing that happens with computer science folks, people with computer science degrees, is sometimes they will devalue a web developer skill set because their skill set is more of a hybrid skill set. They're not just a programmer. They also do some of these other things. In fact, I would say if you had 100 just programmers and 100 web developers, I think you would find more good programmer. I think the average programming ability of the web developers would be significantly higher than the average design ability of the computer scientists. All right. As a general rule, these real programmers who want to go and work for Acuity, things like that, they're not interested in user interfaces. Somebody else makes those look nice and things like that, or we just make it look functional. We're into it for the real code, right? And we're going to see that in Android Studio when you see my beautiful interfaces this semester. Okay, because I'd like to think that I'm truly gifted at bad interface design. So yeah, I don't teach those classes. so go talk to somebody else if you want good interfaces. But, yeah, Dr. Wall would be good at making things look nice. And then Dr. Locklear and Professor Locklear both teach the human-computer interaction class, which deals less with making things look artistically nice, but more with kind of the correct interface for user experiences.
I noticed that you differentiate the Locklears. Who do you consider the professor?
Dr. Locklear is the old guy because he has a PhD. Professor Locklear is the young guy. He's working on his PhD.
Got
I call them Josh and Gary.
it. I'm just saying,
I call it
student.
drinking.
How did I get? I don't know what you're talking about.
Old guy is doctor, young guy is professor.
Yeah. Okay. That makes more sense.
Yeah.
Welcome to Disney Channel. First taking notes. I call it drinking.
Well, I mean, the thing is that some teachers are very particular. I don't know necessarily if they are or not, but they're particular about titles. I'm not. So people call me Littman or whatever. I'm not a formal person, but I don't, but I'm a doctor too, so I can call them by their first name. It's a rule, right? It's like a rule.
Like if I walked up to him, I was like, "Hey Gary," he'd be like, "All right."
It might be weird. Yeah, it might be weird.
Yeah,
Yeah, no, I don't know. My off topic, I guess. So my gut feeling would be he would be less concerned about it, just because of how long he's been teaching. At some point, you just get desensitized to it. It's like, where Professor Locklear, because he's currently working on his PhD. When you first get your PhD, it's like this big deal. You want everybody to call you doctor. But then it's no longer a big deal. Right, that's like this big life moment when you finally finish like this death march. But
Then you're just that guy.
well, yeah, I mean, then it's well, yeah, then it doesn't matter. It was an important part of your life, and when it was, you're close to it, and you saw the sacrifices you had to make. That's the thing. But after it's 10, 15, 20 years removed,
I'll start calling him doctor.
it doesn't matter. Yeah.
Yo, doc.
So the only person I make call me doctor is my wife and, well, two people, my wife and my mom. It is funny. My mom and my grandma, I have one living grandparent. They both, every single time they write something, they want people to know that their son or grandson's a doctor. So they write it all out. I have like trouble cashing these checks.
Sure, we need to see.
It's like they're like Dr. Michael Littman, and like all my stuff, even my driver's license says Mike.
So
It's like that is not my legal name. My legal name is Michael, but I don't go by Michael.
Yo, I'm like,
Sir, we need you to identify.
bring your transcript with you.
Where's your fingerprint?
Nobody cares.
Except the bank.
They actually don't necessarily care. It's
Well,
usually depends on the size of the check. $50 check, they'll pretty much cash anything. You start adding zeros onto the end of it, they get a little bit more
they'll
picky.
start looking at it.
yeah, I'm sure your checks are $50.
Well, some of them are.
Maybe.
All right, so kind of rolling back in time, one of the things we see, and let me actually, just so I can explain this, let me show you, we'll add a tab. Should we add a tab?
Oh,
690.
Yes.
I counted them.
All right.
Fast. You're up to like 70. Doesn't look
How
too
many-
bad for this.
So-
How many tabs do we do?
All
I
right,
think
so
I count them. 1, 2,
here's this going to give me something that I want.
6, 7. There's more than 30 up there. Looks like at least 20.
Yeah, I want to show you what I'm getting at here. I want to show you the problem that MVC is solving. This is what I want. PHP code in. Okay, this'll work. Can I? All right, we can see that. Okay. Really short web page here, so it doesn't necessarily drive my final point home, but this is an HTML document. Okay, but it is actually saved as a file called something.php. All right, this is called something.php. Now, what that .php says is it wants somebody else to pre-process it before it spits this out to the web page. All right, because my web browser, it knows how to handle HTML, but my web browser does not know how to handle PHP. PHP is something that gets processed on the server side at whatever web server I'm talking to, and then it's spit out to me as HTML, JavaScript, and CSS. Your web browser at the end of the day will accept those things and will make it look pretty on the screen. All right. But if I want to have some dynamic logic in my site using something like PHP, I have to name my file with a .php extension instead of a .html extension. That way it gets handled specially on the web server before it just feeds me the answer. All right. But here's the problem MVC was built to solve. This is a very simple PHP website, but we have, this is an HTML tags. This is just HTML. This is just HTML. This is just HTML. Now, right here in the middle of the page, we've embedded some PHP. So we have this little special PHP flag here with the closing tag. And this says that for this section, when you're going through the PHP preprocessor, it's going to look at this and say, it wants me to do some interpreting of this and ultimately boil this down to just saying hello world, kind of like spitting out that text. So it executes this code, this like micro program, if you will, ultimately producing code that's just HTML and JavaScript and CSS. All right, now we're back to just normal HTML, normal HTML. So in this website, we have just some PHP stuff here, and we can have PHP stuff like that strewn about our page. Now you can imagine as pages get more and more and more complex with more moving parts on them, do you think that if I were looking at the page source, it's going to get a whole lot scarier than that? I mean, I just looked at the page source of Google's page just a few minutes ago, which doesn't look like it holds a whole lot of stuff on it, but it just was a wall of stuff. So if you went to some really advanced PHP site that had, that did a zillion different things, chances are that's a very complex application behind the scenes, right? So if you had your interface stuff, that's interface stuff. That's what it looks like, mixed with your implementation stuff, your controller. So this is how it works. This is what it looks like. If we mix those things together inside of one document, as that page gets more and more complex, we can imagine that that document becomes fairly difficult to manage, right? You would rather have a single screen that makes where you've defined your entire interface and then somehow connect that to PHP code that lives someplace else that does some pre-processing stuff and just delivers you the data that you need, rather than having them both live inside the same file where that file now becomes difficult for you to edit or find bugs in and things like that. Makes sense where the issue is here? All right, so if we kind of just go back, the issue with PHP, web-focused language, this is what web looks like. We're going to say complex PHP pages had many, many lines of HTML, JavaScript, CSS, and PHP code all embedded inside a single document. Too much code to deal with in one place. Does that make some sense? This wouldn't have been a problem in the early days of the web where our websites were very simple. Now our websites become a lot less simple. We can do really complex things inside of websites, which then comes with more complex code behind the scenes. So we'd like to keep these things in separate places and then somehow glue them together. All right. So everybody understand the idea of what MVC is solving? Okay, separating your code. We're not talking about your actual data here, but some websites talk to data as well. So if you go to Amazon.com, the data lives in some database over at the Amazon company, right? Probably strewn about the world at a bunch of different server locations. Then your interface is what's shown on the screen. And then you have the dynamic interface logic that's going to sit on the server behind that interface for driving that dynamic interface. Okay. So how is this done in Android Studio? So we're going to look at this from the perspective of a screen in an Android app. Now, what we're talking about here is going to loosely translate to iOS as well, even though their way of accomplishing this is a little bit different, but it's very similar. So screen in an Android app has something called an activity. So we're going to call this guy our interface. All right, so we have an activity. Then we have, I'm sorry, this is our controller. I apologize. All right, then we have this, and I'll actually show you over here in, so we have something called a layout. This is our interface. And then somewhere else, we have I'll just say database. This is our model. Now, for right now, I'm going to kind of throw the database over here. Historically, we've done a poor job in our classes of giving you guys practical experience with this database piece. What ends up happening is you get into the 430 database class and you learn about database theory, which is important, but that class hasn't connected the applied side to it. But we actually need to do even beforehand. So my goal in here and in the next class after this is that you will get plenty of practice having your applications talk to a database. You don't have to know how that database works. You don't have to know about database normalization and some of the theory stuff that Dr. Wall is going to talk about. But when you walk into that 430 class, I want you to be comfortable with what a database is and what it's used for. So that when you get to that class, you have kind of a context in the world of development of why is it important that I'm learning this database theory. And then we're going to do database. In that class, you'll be exploring it through some web programming type stuff. So that's kind of some of the changes we're making. But in here, I'm not going to do very much talking about how the database works. In fact, we're going to be using a non-traditional database called Firebase in here, which is not a relational database like MySQL. But from our perspective, it doesn't matter. We're going to think of a database for us as a remote place to store our data. That's what it is. It's a bucket that lives somewhere where we put our data in it and our program can access it somehow. Make sense? All right, so I'm going to kind of put this off to the side for right now because we're not going to deal with that at first. All right, but know that this is our model. That's that piece it's talking about. Okay, so we have our activity and then we have our layout, our interface. And then these two guys, are connected somehow. And we're going to look at how Android Studio accomplishes that. Similarly, our controller has to know how to talk to our database if the application that we're working with has a database. Now, keep in mind that this database thing here does not give us any information about where that lives, what the nature of it is. It's a place that holds data that persists through runs of our application. This can happen as this local little file in an Android application. It could happen in a Oracle super expensive database that lives at Amazon. Okay, it could be all over the place. But this just implies I have data that needs to survive when I restart my phone and launch the app again, for example. I don't want to have to re-enter in all my basketball players, right? Every single time I want to test my app. Initially, that's how we're going to do it. But then we're going to start looking at ways we can store stuff so it lives through runs of our application. But in here and in the next class, we're not going to talk deeply about how that's working. We're going to be talking about how we interface with it. Make sense? Not how it's built. That's the 430 class. All right. But initially, we care about this world right here. This is our starting point. All right. Questions about this? All right. So a screen in an Android application is represented by an activity where that activity is linked to a layout. So if you have an Android application that has many activities in it, many screens, it would then have many activities, right? You go into your bank app or something like that, or your, fantasy football app. These might have 4, 5, 6, 15 screens in it. Each one of those is going to be represented as an activity. And you'll see it sometimes like slide in or slide up. There's some animations that are used when the new screen shows up on. So every single one of those screens would have an activity behind it and a layout associated with it. That makes some sense. And then in Android, that whole world lives inside of a virtual machine. So every single one of your applications on Android lives inside of its own little virtual machine pod, so it doesn't impact other apps on your phone. But that's the way it works. iOS actually doesn't separate things into individual activities like this. iOS has this thing called a view controller, and one of their view controllers is a collection of other view controllers. So your application lives inside of a single view controller, where a single view controller knows how to present other view controllers, where a view controller is like an activity. Just a organization of it. Android just says, here, I just have my activities strewn about here, and I'm going to switch to whatever one. They are all contained inside this virtual machine, so they're not going anywhere. They're not going to escape. Whereas iOS, we can say the virtual machine is replaced with a top-level view controller that holds on to all of those view controllers that make up your app. So it's not so dissimilar. All right, so let's look at our first application here. So I'm going to go into Android Studio. I'm going to close some of these things. I'm going to go to File, New, and when you first launch Android Studio, let me update Gradle real quick. While doing that, let me talk about what that is so it doesn't freak you out. So we have this thing called Gradle with Android. So we have lots and lots of files associated with our Android projects, most of which we don't control. All right, so when we create a new Android application, it's going to generate a whole bunch of stuff that we may never touch. Some of it we have to interface with a little bit sometimes, especially as we start getting into more advanced applications where we need to give like access to certain security protocols and things like that. But bottom line is, for us, a lot of stuff is created that very likely we won't have to mess with, but it's still part of the project. Okay? Then we go and we create our couple of classes that make our simple little app, right? And ultimately what Gradle does, Gradle builds our working Android application in terms of all of those default files as well as the files we have added. All right. It really is doing something even more complex than that, but at the high level, that's what Gradle does. Okay. Gradle is a tool for compiling all of our stuff. If you've done Linux stuff before, Gradle is Gradle is kind of like make. If you've ever compiled a C program and a Linux or a Unix prompt or something like that, you would say like make and then make install, where make has like the special file associated with it that knows all the little things it has to compile before it puts all your stuff together. All right, so Gradle is Java's version of that. You don't have to worry about it because it's all self-configured for you, but sometimes the problems you run into in Android Studio might be Gradle related. You know, maybe some configuration file didn't actually get written the way it was supposed to get written. Sometimes just closing Android Studio and reopening it solves the problem. But sometimes you'll come up with you'll have a Gradle error, something like that, which can be sometimes difficult to debug just because you didn't write any of it. Okay, so usually I say restart the application. Sometimes it is because of your own application. Gradle failed because you wrote something that was not something good to write, right? You have logic errors in your code. In fact, most of the time that's the case. So I don't want to advertise that Gradle is just flaky. It's not. Gradle works. But every now and then something might happen with Gradle that wasn't actually your fault, even though most of the time it was. So if you strongly suspect that your, or even you don't even have to strongly suspect, if you get a Gradle error, close Android Studio and reopen it. The chances of that Gradle error happening again and it not being your fault is slim. Okay, so if you get a Gradle error and you restart Android Studio and you get it again, start paying attention to your code. You probably have a mistake in your code. Okay. Don't show again. All right, so we're opening up Android Studio here. Now, for some of you, when you first open Android Studio, it's going to have a little window that pops up that says, you know, create a new project, some stuff like that. I have that turned off on mine, but what it ultimately will look like if I go File, New Project, when you click on Create a New Android Project, it'll open something that looks like this. All right, so we're going to go through the process right now of making our first app. Now, what they're doing here is they're giving you a starting point, because I said that all applications, if you have one screen in your app, those are represented by activities, right? So I have never created an Android project where I had no activity. But I suppose you might be somebody who's bringing in some other activities from another project and you just want an empty project to bring those into. Maybe that's okay. But the default that highlights here is, I think, basic activity possibly, but I always choose empty activity. Basic activity adds some bells and whistles to it that, you know, kind of forces the way the code gets organized and then forces you into a certain way of writing, certain way of doing MVC. But for us, you know, notice here we have like a navigation activity where you have the navigation bar at the bottom. You can switch between different things. These are kind of common views that you might start with when you create an application. Full screen activity, master detail flow for like tablets, that kind of stuff. You know, we got more. We got a map activity, login activity if you just want to have a username and password and want to fill in the gaps. That stuff. So for right now, we're always going to start with an empty activity. No frills, but it is an activity. So I'll go ahead and click next. You can name your application whatever you want. I'm going to call this guy Hello World Test. Call it Hello World Android Test. Now notice underneath it gives you this package name. It probably already has in there like com.example.whatever. You can just leave that. Unimportant for us right now. Whatever the default is fine. Later on, once you're writing professional Android applications, you might want to have your package names named a certain way because you might have like a suite of applications and want these guys to be related to each other. But for right now, this will work. com.example.whatever. And notice as I was changing the name of my file here, it was adding stuff to the package name, the end of the package name. All right, location where you want to save it, put it wherever makes you happy. the language we're going to code in. Hit the drop down. You have two choices. You have this language called Kotlin, and you have a language called Java. We're going to use Java. Java's by far still the most popular for Android. Kotlin is kind of Android's answer to Swift. For a long time, iOS development was being done in Objective-C. And then Apple came out with a Swift language, and now any new project in iOS is usually done in Swift, which has, some features that might be appealing to some people, but a lot of folks still like Objective-C, but most applications are written in Swift now. Whereas some of those features that are in Swift, so like for instance, automatic error checking of null values, that kind of stuff, is in Kotlin. It has not really taken off, although it's not an unpopular language. Like anybody who's used it typically is impressed with it, but make sure you select your language as Java. Most Android applications are still written in Java. All right, now we have this thing called minimum API language, or minimum API level. So Android's been out for a long time, and the problem is if you're an Android user, your phone very likely is not running the latest, greatest, newest version of Android. All right, even if you've updated it, you might have just updated it for the latest version that's available for your particular phone. Only the Google Pixel phones are going to always have the latest, greatest version of Android because that's the device they were designed for. Following that, you're probably going to maybe get it on the Samsung devices next, because Android's open source. So you have to give these companies time to go in and break the OS by putting their own stuff on it. So, I have a Note 10, which, is the newest Samsung phone, and technically it doesn't have the latest, greatest version of Android on it. It has Android Pie, where the new version of Android, I think, is already released. What's it called? What's the next version of Android? Q? Android Q? Yeah, so that would be on, the Pixels would already have that if it's an official release, not a beta release. But regardless, sometime in 2 or 3 months or whatever, Samsung will finish breaking that and release it to its people. And it'll be on our phone. But the point is when you write an Android application, you want it to run on as many devices as possible, right? So you have to look at what your features are in your app and decide how new of an API do I need to go before all my features I'm going to use are available. If you're writing an app that takes advantage of some latest, greatest feature that just came out in the new version of Android, well, you're going to have to pick the newest version of Android as your target. But if you're making a Hello World app, okay, which is not reinventing the wheel, what you want to do is you want to pick an API level that is old enough that it takes into account the largest number of applications. So the default was the largest number of devices. The default level is API 15. Android Q is API 29. So that is it's 14 revisions of the OS ago is what they're saying. Is most people who have a device today are running at least Android API 15. And Android typically is a superset of the previous version. So the newest version of Android will have everything that the previous version of Android had in it, plus a couple of new things. So typically the default value that's in there, API 15, is going to be good enough. And notice here right underneath it, it says your app will run on approximately 100% of devices. Where if I go down and I select API 29, your app will run on less than 1% of devices.
Seems good to me.
Huge difference.
If I go to Android Pie, now it's at 60. That's actually somewhat impressive. Actually, hold on. No, that's the wrong one. I want to go to Pie. Pie is less than 1%. Oreo, 1.1%.
Woo! Yeah, but 1%.
Oh, here's the original version of Oreo, 6%.
Wait, the original has.
Nougat, 14%. Original Nougat, 37%. Marshmallow, 62%. Kit Kat, 95%.
What's with the names?
That's just what they've always done.
Ice cream sandwich.
So,
Alright, ice cream sandwich.
pick API 15. It says it'll run on 100% of the devices as long as you don't need some feature that wasn't available in there. You can go with it. All right. And leave all the other stuff default. Go ahead and hit finish. And this is going to create a brand new project. And Gradle is building down here. It's doing its Gradle thing. So your structure for a project looks like this. We have this, so basically Gradle, you can just keep closed. All this stuff down here, things we don't have to worry about. Everything we care about lives inside this folder called app. All right, so then So inside app, we have something, so make sure you let Gradle finish running because it reorganizes the stuff afterwards. So we have a folder called app. And inside this, we have a folder called manifest, which we're not going to mess with for a while, if ever. We have a folder called Java. This is where our stuff lives, so we're going to definitely work with that. And then we have a folder called res. This is our resources. And inside of our resources, we have a folder called layout. Okay? And so we have, notice here in the top level, we have com.example, hello world, blah, blah, blah. Then we have an Android test and a test version. Our actual source code is the top one, the one that doesn't say test, anything test in it. These are unit testing, as the book talks about. It's built into it. We might mess with them at some point, but for right now, we'll just not touch them. So one class, Java class, is created for us called main activity. That's this guy right here. And notice he looks a lot like any other Java class we create, but he has this little extends app compat activity, blah, blah, blah. And then notice here we have this function called onCreate. And inside this, this activity associates itself with something called activity main that lives inside of resources, layout, and here's activity main. So if I double click on activity main, it shows me hello world. It's already in there. This is how MVC is happening. This is my controller. This is my interface, my view. And this is how they are connected to each other. We let the controller know which view he will be presenting. All right, then I'll go ahead and hit play. And for a lot of you, this is going to pop up with a emulator run thing. So to be something